let's go to page 167 and let's do 212. Okay, so 212, you want to prove that a trapezoid, if a trapezoid is orthodiagonal, then you have AC squared plus BD squared equal to AB plus CD squared. Okay, so let's go and draw a trapezoid. And let's call it A, B, C, D. And it tells you that AB is parallel to CD, so AB is parallel to CD. Okay, and the diagonal is also diagonal. Okay, and you want to prove that AC square plus BD square is equal to AB plus CD square. Okay, so this one is kind of hard to do, okay, and the reason because that it's kind of hard to visualize. So whenever you can, okay, whenever you're not sure what to do with a trapezoid, you always want to make a trapezoid into a parallelogram and a triangle. Okay, so you want to draw the parallel lines. It's usually helpful. Okay, so what we're going to do is we're going to extend this out, and I'm going to draw parallel line to here. Okay, so again, it's helpful if you draw parallel lines, make it into a parallelogram and a triangle. That will help you to solve a lot of trapezoid problem. Okay, and I'm going to call this E. Okay, now when you draw these parallel lines with this, so this is the parallelogram. Therefore, you can slide things down. So, and this would be same as AB, right? So this is length AB, so it's a parallelogram. So you slide it down here, okay. And you also can slice over, so this would be a AC, right? Because this length is AC, so you slide over. This one you slide down. Okay, now, because this is a right angle and you draw a parallel line, this would be, this will also be a right angle, okay? Because this is perpendicular to this and this is parallel, so this will be perpendicular to that. So what we're going to do is we're going to look at the triangle BDE. So look at this big triangle. So now this is a right triangle, okay? This is a right triangle, so we can apply the Pythagorean theorem. Okay. So this side, so we're going to have the BE square plus BD square will equal to DE square. Okay. And then after that, we can go and substitute. Okay. If you look at the BE is also equal to AC because we just slide it over. So we can switch this become to AC from here, right? Again, BE is equal to AC because this is the parallelogram from this side. So we just slide this over. So BE equal to AC. Now the DE, okay, DE is equal to DE equal to CE plus CD, right? DE equal to CE plus CD. So again, so this whole thing is equal to CE plus CD. Okay, and then but also from you notice the CE is AB. We just slide this thing down, right? So CE is AB, and that's it. That's what we need to prove, and that's it. Okay, so you can draw a parallel line so that you get parallelogram and a triangle. Okay, whenever you can with the trapezoid, make into a parallelogram and a triangle. It will help you to solve many of the problems. Okay, let's go to 213. Okay, so the picture is giving. So this is A, B, C, D, and this is A, B. Okay, and it says the angle B is twice angle D. So this is theta, and this is 2 theta. Okay, and so you're looking for CD. You're looking for CD. Okay, so again, the trick is when you have a trapezoid, you want to draw parallel lines, and so that you will make into a parallelogram and a triangle. So draw a parallel line right over here. Okay, so that this would be, so draw the parallel line, so make into a parallelogram. Okay, so now you have a parallelogram over here, and let's go and call this E. Now when you have parallelogram, if this is theta, then this would be also theta. Opposite angle would be congruent. And we know that this angle is 2 theta, so if this is theta, this would be also theta. Okay. And since this is a parallelogram, this is a corresponding angles, so this would be also theta. Okay. So again, this is the opposing angles, so they are congruent. These are corresponding angles, so they are congruent. And this theta comes from the giving. This is 2 theta, right? And so if this is theta, this is also 1 theta. So now you have, so this is going to be isosceles triangle, because if these 2 angles are congruent, that means the length facing that way congruent also. So if this is A, so this is the A is facing the theta, so this would also A facing the theta. And since this is the parallelogram, this is B, so you can slide it down, so this would be also length B. So now we can see that the length DC is equal to DE plus EC, right? So DC equal to this, and so DC equal to, I'm going to switch the letters, so it would be just A plus B. Okay. Okay, let's go to 214. Okay, so 214, you have a rectangle. You have the rectangle A, B, C, D, and you have the diagonal, and you have a random point P, so that you have so this is P is perpendicular to the DB at S, and you also can draw the perpendicular over here, and then you draw this right over here, and then you draw perpendicular to that. Okay, so anyway, the picture is giving, and all the informations are giving. So this is point, this is T, this is Q, this is R, this is E. Okay. Okay, so you have all this information that it's giving. So you're looking for what's PR plus PS? So you have PR plus PS. So what would that equal to? Okay, so let's go ahead and do some work. So from the giving, PQ is perpendicular to AF. So PQ is perpendicular to AF. Okay, so that means angle PQF equal to 90 degrees. So this is 90 degrees right over here. And BD perpendicular to AF. So BD perpendicular to the AF. So that means angle SFQ equal to 90 degrees. Okay. So SFQ is 90 degrees. And you have the PS is perpendicular to BD. So PS is perpendicular to BD. So angle PSF equal to 90 degrees right over here. Okay. So because now you have 90, 90, 90, so obviously this will also equal to 90 because any quadrilateral, the sum equal to 360, right? So 360 minus 90 minus 90 minus 90 will give you 90 also. Okay. So from this three information, okay, therefore angle QPS equal to 90 degrees. Okay. So now if you look at the PQFS, okay. So if you, because now you have four right angles, so it's going to be, so it's a rectangle. Okay. Now once you have a rectangle, then AC, so AC equal to BD because the diagonals are congruent, and then AE equal to BE. So AE equal to BE. Okay. Because all these would be because the diagonal of a rectangle bisect each other. Okay. And therefore the ABC ABE is isosceles. So ABE is isosceles. So they keep that now there for now. Okay, now so you have so since it's isosceles, so if this is isosceles, so angle EAB is equal to angle EBA. Okay, so this, so again you have to mark this as you go. Okay. Okay, the next thing is PQ is parallel to FB. Okay, so PQ is parallel to FB because these are two sides, opposite sides of the. These are opposite sides of the rectangle. Okay, now because these two are parallel, these two lines are parallel, so these two angles will be corresponding angles. So angle APQ is congruent to angle ABD. Okay, so these two angles are going to be congruent because of corresponding angle, because these two lines are parallel, so it will be corresponding angles. So by looking at the marking, you can see that this angle and these angles are congruent. Okay. So you have angle TAP is congruent to angle TPA. Okay. And therefore AT is equal to PT. Okay, because this two length, this is facing the one hash mark, this is facing one hash mark. So this is congruent to that from this isosceles triangle. Okay. Next is that Okay, I'm going to do it right over here, continue up here. Next is an angle ATQ is congruent to angle ATQ is congruent to angle PTR. Okay, so this angle would be congruent, and because they are vertical angles, okay, because they are vertical angles, okay, vertical angles are congruent. So now you can see the two triangles are congruent. For the right triangle, this would be the HA, okay. So triangle ATQ is congruent to triangle PTR. So now these two triangles are congruent. Okay. Now if the two triangles are congruent, then PR, so PR will equal to AQ. Right? Again, if these two triangles are congruent, then use a CP/CTC. So this will congruent to AQ. So PR congruent to AQ. The next thing is PS is over here, and since it's a rectangle, you just slide these things down. So PS will equal to QF. Okay, because the opposite sides of the rectangles are congruent, okay, or equal. Okay, so opposite sides of rectangle are equal, right? They're congruent. And so now all you have to do is add these two together. So if you add these two together, you have PR plus PS equal to AQ plus QF. So PR plus PS, so AQ plus QF, if you look over here, AQ plus QF is equal to AF. Okay, and that's it. That's the end. Yeah, so this proof is a little bit lengthy. Okay, let's go to the next one. Okay, number 215. Okay, so you have a parallelogram. And this is A, B, C, D, and it's giving that AB equal to 3 and BC equal to 5, and area is equal to 10, and it gives all the information to locate the point. So AE is equal to this point right over here, so that's 2. And BF HE equal to 2, so BF equal to 2, and AG equal to 2. Okay, so you're looking for, oh wait, then you have so you have a line through G and parallel to EF. Okay, so you're gonna, so here's EF, so you're gonna have a parallel line through G. And this is H. Okay, so you're looking for this area right over here. Okay, so first what we're going to do is we're going to draw the GF. So if you notice that this is a 5, so this is a 5, and this is 2, so this will be a 3. Now because this is a 2, this is a 2, so this is going to be parallel, and this will be parallel. So this will be a 3 here, and this will be a 3. Okay. and this is 2, so this would be a 1 over here. Okay. Okay, next thing is that since these two are parallel, okay, so this will also, if you draw this over, this will be kind of parallel too. Okay, but you don't need all that information. So let's go through this. Okay, so start with the area. So ABCD is equal to 10. Now, if you look, since both these are parallelogram, okay, and they are ratio of 2 to 3, right? So, and you just divide this by 2, right? Because notice 2 and 3 give you 5, and this area is 10. So just multiply by 2, right? So what I'm saying is the area of a CDGF is going to equal to 6, and ABFG is equal to 4. Okay, again, because they have the same height and the ratio is 2 to 3. Okay, so you can do this. So you can put a 3n plus 2n equal to 10. Okay, and so again, just look at the area. So 5n equal to 10. So n equal to 2. So if you multiply by 2, you get 4. Multiply by 3 by 2, you get 6. So that's the area. Okay. Then after that, you look at each individual. So notice that the triangle is half of the parallelogram, right? So the area of FGH, the area. So you can just look at this part over here. So the area of the triangle is 1/2 base times height, and parallelogram is just base times height. So triangle is half of the parallelogram. So this will equal to 1/2 of the CDGF. So area of the FGH will equal to 3. Same thing over here on this side now. I can just look at this over here. So the area of FGE equal to 1/2 ABFG. Okay, so again, the triangle, the area of the triangle is half of the parallelogram. So area of the FGE equal to half of that is equal to 2. Okay. And so now the area of the shaded area, so HG will be just adding these two together, so it will be equal to 5. Okay, and so that's it for this one. Okay, let's go to 216. Okay, so you have a convex quadrilateral ABCD, and okay, you want to prove the 216. Prove the isosceles trapezoid. Okay, so this is the isosceles trapezoid. So this is A, B, C, D. Isosceles trapezoid means two legs are congruent, and it's also diagonal. Okay, so the diagonal diagonal means this is a right angle. Okay. And you want to prove that the altitude, they also draw the altitude over here, and they call the x and the y. So let's go and call the x and the y and call this point E. So you want to prove that the altitude is equal to AB plus CD over 2. Okay, since this is isosceles trapezoid, that means it's always symmetrical. So if you draw the altitude down, this will also symmetrical. Therefore, this is the midpoint. Okay, so this is going to be midpoint. So you can, because the symmetry isosceles, when you draw the altitude down through the point E, it's going to be all symmetrical. Therefore, this has to equal to that, and this has to equal to that. Okay. Now you have to use the theorem. Now, since this is a right triangle, so when you have a right triangle, the midpoint. So this is a hypotenuse. So this is the midpoint of hypotenuse. The midpoint of a hypotenuse of a right triangle is equal distance to 3 vertices. That means the YC. So that means YE is equal to YD equal to YC. Okay. So again, the midpoint of a hypotenuse of the right triangle is equal distance to 3 vertices. And therefore, this is going to equal, since this is the midpoint, this would be, so each of these would be equal to 1/2 DC. Okay. So again, each of these is 1/2 of that. And you do the same thing with the triangle up here. Again, this is the right triangle, and this is the midpoint of the hypotenuse of the triangle. Therefore, it's equal distance to 3 vertices. So by using the same thing, so you're going to get XE is equal to XA equal to XB equal to 1/2 AB. Okay. And so the altitude, so if you kind of add this together, so YE plus XE, so YE plus XE equal to, so YE is 1/2 DC. And XE is 1/2 AB. Okay. And so now you arrange things a little bit. So YE plus XE equal to XY. And you can factor out the half, so put underneath. And on top, you kind of rearrange, so you get AB plus, arrange the letter, so CD. So put this term over here, put this term over here, and switch the letter. Okay, and that's it. That's all you need to prove for this one. Okay, let's go to 217. Okay, 217. You have a convex quadrilateral. So let's go and draw that. And label A, B, C, D. And okay, they E be the point of intersection of the diagonal. So you draw the diagonal. And this would be point E. And then you're going to have, so they PQRS be the center of the circle circumscribe the triangle. Okay? So now in order to circumscribe, you have to use the perpendicular bisector. Okay? So you get a perpendicular bisector of each. So that for this triangle, the circumscribe center, the circumcenter would be right over here. So you have to get your perpendicular bisector. Okay, so get your perpendicular bisector. Okay, so I'm going to put this right over here, so call this P. Now, it may or may not be on the line. Okay, it's pretty close. So for the triangle ABE, the circumcenter is right over here. Now, let's go and do this one here. So locate the center and draw the perpendicular. Okay, and that's going to call it Q. Now let's go and do the circumcenter for this triangle over here. Okay. So PQ, let's call this R, and this is S. Okay? Okay, so you want to prove that this is a parallelogram. Again, my picture is a little bit off, so it may not be as accurate. Okay. Okay, so first, so again, all these are perpendicular, right? Because that's what the perpendicular bisector means, right? So you draw the perpendicular, you draw perpendicular, and over here you draw perpendicular to that. So all these are perpendicular bisector. Okay, so first you have PQ is perpendicular to BD. Okay, so again PQ is perpendicular to BD, right? Again, that's a definition of perpendicular bisector. So since this is a perpendicular bisector, this will be perpendicular. And SR is perpendicular to BD. Okay, so SR is perpendicular to BD. Okay, from the marking we have. Okay, again, because this is a perpendicular bisector, so you have to be perpendicular to that. So from here we can see that PQ is parallel to SR. Okay, so PQ is going to parallel to SR. Okay, and again, the reason because both of these are perpendicular to the DB. So again, if this is perpendicular to that, this is perpendicular to that, they have to be parallel. Okay. And you do the same thing. You have the PS is perpendicular to AC. So that's this one, and this one here. And you have QR perpendicular to AC. Okay. So now you have this perpendicular to AC. You have this perpendicular to AC. So from here you can see that the PS is parallel to QR. Okay. So this would be parallel to that. And so from here, since you have two pairs of opposite sides are parallel, so you can see that PQRS is a parallelogram, okay? And because you have two pairs of parallel sides. And that's a definition of parallelogram. Now you got two pairs of the parallel sides.